Alright, so everyone, welcome to another Computer Science Club meeting. Before I get started with the activity, let's just run through some information. Um, so important dates is that USACL's US Open is going to be open on April 2nd to April 5th, and that's going to be the last competition USACL is going to have for quite a while. And next week is spring break, so there won't be meeting on the 7th. And on the last meeting, our very last one will be the 14th, the week after. So I'm going to leave this up for about 30 seconds. You can look at it, take a picture. Uh, yeah. Hey, hey, so today we're gonna begin sort of a competition thing where you're gonna create your own bot to play other bots in rock paper scissors. So we have this little um I guess, interpreter kind of thing that would basically pit two different bots together. And so I'm going to show you how to make a bot to play rock, paper, scissors. And then over spring break or whenever you have time and you feel like it, you can make your own bot. And on the 14th, we're going to hold a mini competition. And yeah, we're going to see who can make the best rock, paper, scissors bot. So first of all, to get started, the engine we're using, they provide, they call on a function within your bot. So you want to first set up a function called move, and that's going to be what our rock paper scissors engine is going to be using to get the next move from your bot. And then after that, oh, it sends out two parameters. It has two parameters, my history and their history. And what this is used for is that the engine will actually send to your bot the entire match history. So your bot can look over the history of the matches it played and try to use information from there to get better at rock, paper, scissors. So you can use these information to try and outsmart the bot you're facing against by looking at history and looking for things like patterns and whatnot. But we'll do that later. For now, let's just see how we can actually send replies back. So um, for this one, let's just make a random plot. This one will send a random selection back to the engine. So either throw randomly rock, paper, scissors with no pattern. It doesn't look at history. It just throws something random back. So what you could do is you could just um, you can first of all you have to import a module, import random. So this is like random will has functions that could allow you to choose random items from a list or to create a random double or a random integer. And so we're going to be importing that. And then with that, we can choose a random element from an array. And our array, the responses you're going to be giving, so both my history, their history, and the response you're giving back will be in the form of a character, and it's going to be either R, P, or S. So if we type this in, what it does, what it does is it chooses a random element from this array of three elements. It's going to be either R, P, or S. It's going to choose random one and store inside choice. Then all we have to do is just return choice, and that will send either rock, paper, scissors back to the engine. And for a little description, we can add in a variable that just holds a basic description of a bot. So the engine we're using actually displays the description, so it's helpful to keep track of whose bot is whose. So if you're making your bot, you can put your name down here and then put down your strategy. So you could put like Bob and then like random. So you have your name, so we know whose bot it belongs to, and you have like a little strategy, like what your strategy is, so we can kind of understand your bot better. But for now, this is just a demo bot. You could just put down random. And this would just return a random choice RPS. Now, if you want to actually make it a tiny bit more complicated, you can start looking at history. So let's move on to the next spot. And for this one, the strategy name is going, oh, wait, did I? The strategy name for this bot is going to be we throw you throw rock in the beginning and paper on even throws and scissors. I know, let's just shorten rock first, paper, even, scissor, odd. So what we're going to do is we're actually going to start looking at the match history to determine whether to throw rock, to throw paper, or to throw scissors. So what you can do right now is we can just simply create our move function with my history and their history. And now what you want to do is, so my history and their history return an array of all the past history. So depending on what round it is, it'll have that many elements -1. So if it's round 1, it won't have any elements since there hasn't been in history. If it's round 2, it'll send back an array of length 1 because it has been one match and they have one history of a match being played recorded. So maybe you guys both throw rock in the first thing, then for the next move, they'll return an array that has the character R and then another array here that has the character R for both your move and their move. And then on round 2, let's say you throw scissors, they throw paper, then my history will have R and S, while their history will have R and P, and so forth. And so if you check length of my history, you can check what round it is. And if we just simply do like less than 5, then it just means as long it'll keep throwing rock or keep running this part as long as it's under round 5. So round 1, 2, 3, 4, 5 will have length 0, 1, 2, 3, 4, and those will all throw whatever we choose here. So we can just say return R, and that will throw rock for rounds 1 to 5. And then let's say if it's not, then return statements will basically break out of the function. It'll immediately go back. Everything after the return statement won't run. And if it doesn't run this return statement, then it'll just continue on the list. So we can continue on. Let's say else if length of my history mod 2. So what modulo is, this little symbol here, modulo is basically find the remainder when you divide two numbers. So quick explanation, 7 mod 2 equals 1 because when you take 7 divided by 2, you get 3 remainder 1. And modulo takes out the remainder, so you get 1. And for bigger numbers, you do 39 mod 4 equals, and the answer is 3 because 39 divided by 4 is 9, remainder 3. And if it's a perfect number, if it's like 40 mod 4, then it'll be equal to 0 since there's no remainder. So that's how modulo works. And if you do mod 2, you could check whether it's even or odd. If it's an even number, it'll be equal to 0. If it's an odd number, it'll be equal to 1. So we could just check if it's equal to 0, which means it's an even number, then we just return paper. And if it's not, just return scissors. And why you can just return scissor without putting another else if to check whether it's odd or not is because if this fails, it means it's not even, and if it's not even, it has to be odd. And you don't need another if statement because the only way it'll get down here without getting returned by either of these statement if the length is greater than 5 and if it's odd. So you don't really need another if statement, and this is going to be it for for checking the length of your history and throwing based on what round it is. Now, if you want to actually check the history, like actually look at what people have thrown, you can start looking at the elements within the array. So for this one, what we're going to do for this one is very common is beat last move. So if they threw rock last move, then you will try to beat rock this move and throw paper. If they threw scissors, you'll throw rock this time. If they threw papers last round, you'll throw scissors. I think I repeated myself, but anyways, you get the idea. So you're trying to beat the very last move that the other person threw. So we just define move, my history, their history. Yeah. And then, yeah, so now to actually check, because these are array, you can just grab an element by just doing something like this, and then the number here. So the first element will be 0, the second element will be 1, the third element will be 2, and so forth. But we're trying to get the last element because the last element is the most recent one, or the previous move. Previous move will be the very last array. And there's two ways you can do this. You can either do length of their history minus 1, which means that if their length is 5, then the very last index will be 4. So 5 minus 1 is 4, and that's how you get the very last element. Or if you want a simpler way that doesn't need calculation, you just do -1. And -1 will just get backwards. So -1 will be the last one, -2 will be the second to last, -3 will be the third to last, and so forth. So let's just make a visual representation here. Let's say you have an element, or you have a array that's like A, B, C, D, E. This one will be element index 0, index 1, index 2, index 3, index 4. And going backwards, it's -5, -4, -4, -3, -2, -1. So that's how you, index 4 in this case will be the same as index -1, index 3 is the same as -2, 2 is the same as -3, 1 is the same as -4, and the very first one is -5 or negative length of array. So you can use negative to get the very last element, and after this, let's store it in a variable. Let's call it their last. Or you know what, let's just last. Now that we know what their last one is, we can just try to beat that one. So if last is R, then we just return paper this time. And if last equals paper, then we return scissors. And if last equals scissors, then we return rock. And this is how you would beat the previous move they threw. So this strategy will work very well if people start repeating throws a lot, and against bots that would like repeat their throws. And how much time do we have left? We have a bit more time, so let's just do one more thing. To help your process along, we can create another function called beat this. Oh, wait, just what we can do is create a function that will just check this thing for us. So we don't have to type this thing every time. So when you create your own bot as team 6, you won't have to rewrite this entire thing. We could just create a function that's called beat throw and change these to throw. And now what this does is when you call on this function, it will just return the winning move against that whatever you threw in. So we could just very simply type this. So then what it'll do is it'll check the very last move. So if it's rock, it'll store rock in last. Then it'll call on the method beat this and use rock, provide rock as a parameter. And for rock, it'll return paper, and then it'll return paper back. So you can kind of like clean up your code and make it a bit more modular by this method. And so yeah, and then here is our here's the engine that we kind of just stole from POTW. But yeah, over here you can see if we run this, Windows in a way up. If we run this, you can see that it creates sort of a round robin tourney, and it displays all the wins and losses against each person. Or let me make it a bit wider. Mine doesn't want to. Alright, so it'll play a round robin style, and let's just look at one of the. Oh wait, I forgot to save. If you wanna test this, don't forget to save. Uh, there we go. No strike. Eh. Oh. Ah yeah, one more thing. Actually, I forgot this. Where's team 5? For beat last, I forgot to mention one thing. Since -1 is the very last element, but then an issue might occur if your array doesn't have any element in it. So you want to first make sure that there has been a history. So we could do. So if the length history is 0, then it obviously can't get the last index because there isn't any elements in the array. So then you just throw back rock as sort of like a default movement. So always throw rock first thing, and then now we can try it. Yeah. Okay. So let's just. Where is team? Yeah. Let's look at this one right here. So this one is between two of the bots. That's team 3 and team 5, which is the first one is the rock first and then throw paper even alternating, and then the second one is beat last move. So you can see for the rock first paper alternating, you can see that it does in fact throw rock for 5 times in a row in the beginning, and then it alternates between scissor paper scissor paper scissor paper scissor paper. And while beat last, they threw rock first, and then they start throwing the thing that will beat last one. So paper beats rock, so it throws paper paper rock paper rock. Up to this point, it does fine, but then after that. Since it threw scissors against him, they try to throw a rock to counter scissors, but then that loses the paper. And then since they threw paper, it throws scissors next, and then that ties against scissor, and it just tries to beat the previous move. It doesn't work all the time. And if you look at the right here, you can see the score: 58 wins, 4 loss. Wait, 58 wins, 4 losses, and 48 ties. Yeah, 48 wins, 4 losses, 48 ties. So yeah. And then you can see here team 6 is the bot I made, and you can see it does quite a bit better. It like this kind of, yeah. Anyways, yeah, now you know how to program a bot, and now I want you guys to whenever you have time or something, you can try to create your own bot to play rock paper scissors, and we'll provide you these files, and the winner might get something nice or something. Yeah. Yep. Cool.
Wait, Josh, we're done?
Yep, we're done.
We still have 14 minutes.
And yeah, if you guys want to get started and you have any we'll stay here for a bit, and if you have any questions, feel free to ask. Or if anyone here have an idea for sixth bot, I can make one right now. You can just give me a description. I'll walk you through how to make it, and then you can develop off that. So if anyone has any ideas, any strategy for rock paper scissors, I can make one right now, and you can see how to. Um,
Can you make one that keeps track of, the opponent's moves and they like, they learn it, like machine learning or something?
yeah,
They're
that's
like,
that's team 6. That was team 6.
oh, I wasn't paying attention.
Yeah, if you.
Yeah, unlucky.
I don't want to show team 6 because then they might copy it off. But yeah, so I'll tell you the strategy for team 6, I guess. Team 6 looks for pattern. I'm not sure how well it is because I don't even know how it works. I kind of did
Wait,
it,
show
it
the
ran
code,
to
show the code.
errors. I deleted some stuff and it works.
Wait,
But
can I see the code again?
huh?
Show the code. Can I see the
They're
code
gonna
again?
copy it.
Okay. Can you send me the code?
I'll tell you the strategy. All you need to know is the strategy. Okay, just by
Yeah.
giving you a strategy, you can already pretty much develop the code from it. So, if you paid attention and you try a bit, you'll be able to get it from the strategy. So the strategy is you check for patterns. You look for patterns. So if you see here, um, hang on, I can't find a good one.
Wait,
Where's
is
Team
Team
Six? Team
Six like your
Six.
own team?
Yeah, Team Six is my own team.
That's yours. Oh, okay, I got
Okay,
you.
so
I got it.
actually the engine is kind of wonky, so it's actually lost and wins and ties for this one for no apparent reason.
How
Um,
good is your team?
actually, yeah.
2276
So
2. Oh,
obviously,
okay.
you can see here that it pretty quickly notices a pattern between rock and scissors to beat against scissors paper, and it just kind of breezes its way through. But what it does is it checks for patterns. It checks um I don't know what to choose because they all look kind of random.
Wait, how many games are being played? How many is that?
We can do anything. I say about 100 to give them time to
100.
learn, and so that we can actually
100
see the
games.
response.
Okay.
You can go to 1,000, but then if people start checking entire history, it'll
Wait, so
it'll take pretty long to actually run through them.
this has to be in Python, right?
Yeah,
We
it
can't
says in Python.
unlucky. Wait, so does yours just like it just looks at like the longest length so far, and whichever one's like most common so far, and just outputs the
Yeah,
best it
yeah, yeah.
can.
Basically what it does is it looks at the last one that the opponent threw, and then check to see check to see how many occurrences it has, and then to see what it throws next after that. And then it goes back to 2 elements, then 3 elements, then 4 elements until it runs out of elements. And also checks against its own. So it checks whether it checks what the opponent threw last, and like second to last and third to last and so forth, and also checks where they win or lose. And then using those data, try to figure out what their next move is.
Huh. Got it.
So it's just pattern prediction.
There's really not that many possible pattern like algorithms you can really
Yeah,
use,
but
right?
what you can try to do is you can try to do big brain plays and outplay your opponent by luring them into a pattern and then
Yeah.
breaking the pattern.
Yeah, so like you take the first 20 games and you analyze those games to see which of
So
the
what you,
patterns it is.
you
And then
use
from
their
there,
algorithm to analyze what you're going to throw next, what they think you're going to throw next, then you throw the thing that win against what they throw against you, and reverse psychology your way out.
okay, pretty interesting.
Anyways, yeah. So
I'm gonna create my
yeah,
own.
if you want to participate, go ahead. Good luck to everyone. It's deadline is the 14th, right? 14th.
Yeah, next time we meet.
4/14th.
On the 14th, we'll go over the US Open contest. That'll take me like, I don't know, half the meeting, depends on time. And then the rest of the time, we'll finish this up.
Coolio.
Should we go for like 1,000 rounds for it to actually learn?
That's what
I
I
mean,
was
you
thinking.
could, but
Yeah.
like, I mean, there's only 3 options. It's not gonna take that long to figure out a pattern or learn from only three
You never
choices.
know. Maybe the
And even if you do a
patterns
thousand,
complicate.
if people start getting really complicated, because I'm
You
pretty
know,
sure
Josh, do 1,000 right now and see how
mine is
good it
very
is.
unoptimized. So I think 1,000. I think it could still do 1,000. I'm not too sure. Yeah, 1,000 is fine, but yeah, here you go. Here's 1,000.
Oh my god, what is this formatting?
But to be honest, at least for mine, it doesn't really change much. Somehow it doesn't. It just
Wait, is it win loss tie or
this is
loss
win loss tie. Yeah.
win loss tie? Okay.
You can see the pattern prediction is 3 times better, but then I don't know. It still kind of commits not alive. Mainly about random, because random is a stupid team.
Yeah, random's kind of broken.
Random's a very stupid team.
Wait, but isn't technically like random like math.random is like not actually random?
Yeah, but like,
Didn't I read that
but
somewhere?
the pseudo random is good enough that you can't really
Hmm.
find patterns within 1,000 moves unless you try to reverse engineer their seed and try to find their seed or something.
I feel like every like super good algorithm, like really good one, they're just gonna get destroyed by random.
Yeah. Anyway, so yeah. Uh,
Okay. Uh, pretty much done. Like,
yeah, we're done.
I guess let's wait like one more minute, and then I think we're
If no
just
one still
gonna
has any
run the video.
questions and no one has any strategy they want to see, uh, you guys. I'm actually kind of curious. Can we actually reverse engineer or okay, can we outsmart the pattern prediction by pattern predicting the pattern predicting?
Well, I mean, hmm, I think you can, but
What? Why
like
not?
you can if you hard code it in. But like, how
No,
do
you
you?
don't have to. If you can just yeah eat their code out and then paste it in here
But like,
and
how would you know that they're using pattern
switch
recognition?
their history with my history. I mean, there's only that many learning algorithms you have. Uh, now if you go to the YouTube and you play back the video in slow motion, you can just copy the code, but whatever. Um,
I think I was in there. All right. I think we're good.
yeah, we're good.